Hello friends and hello student. In this session we learn the break statement in C language. So yes, first I share my laptop screen and here fix the position so you can watch my video better way. And here turbo C++, I just double click and take some time process, and now yes is open. Alter F file menu, and here our goal of this session, that is understanding the break statement. And break statement known as a jumping statement. C language, there are, we can say that exactly four jumping statements. So break, continue, go to, and return is also jumping statement. But there are main we can use is a break, continue, and go to statement. Go to is a unconditional jumping forward and backward. So what is a forward jumping and what is a backward jumping? So difference. So break, when you can front of cursor go, that is a means front, that is a forward jumping, and if you back of your cursor, that is a backward jumping. So break is a backward jumping statement. So here we can first define our header file, and we can understand one example to uh, break keyword or break jumping statement. So stdio.h, then conio console input output, and standard input output, and then void main, and then here our goal, that our definition you have to know very well. In my every video lecture, write a program to enter one integer number, and uh, we can say that and I just in second line find out find out that number is prime or not using break uh, statement, that is must be. So I define that definition. So in that is my technique. First you can find the what is input, then what is a process, and then what is your output. So number is prime or not, that is our output, and one integer, that is our input, and in between we can process, find out that uh, output, that number is prime, and using that is here I define that is a break statement. So in my previous video lecture I also some that is a number is prime or not, that taking the while loop, but here I use the for loop. So all loop you can use any program, but we in also my watch the video lecture which program better for which loop, comparison of in exit control loop and entry control loop. So there are three main categories, a two exit control loop and entry control loop. So entry control there are while and for loop use, and do while is the exit control loop. Entry control loop is a for and while loop. So yes, I first save this file, and here we can say that we main our target, we can understand the break, and I just that is break is a keyword, so we cannot give our file name. So break statement sta, but how many letter? There are 5, 6, 7, 8. So there is some wrong file name. So here yes, break st statement. So just first two letter. So if you also provide like break and statement, so there are three first break and statement. So dot c must be, because that is a C turbo C++. If you not provide the extension, then it is save as a C++ file. Okay, so here our target, we can take I and then our number, okay, n, okay, that is our number is a prime or not. Okay, so clear screen. Then we can take the number from user. So here we can say that enter one integer number, that is our input. Okay, so here we can scan the n variable. Yes, that is a percentages in between double quotes, percentage d for decimal, and that is a integer data type. And now here I take the for loop, not a while loop. Also you can use while loop, is a very number programming is very perfect, but here I use the, and we can start our I as a 2. So first you can I think you can know very well what is a prime number. So like 5 I give first we can understand, then we can that is a paperwork I my every definition what is a prime number. So then and then we can solve our definition. So I can say that pi is a prime number. Why? So prime number definition is a which number is a that number is a prime number which is only divisible only one and number itself. That number is a prime. So that number we can say that only two factor, that is second definition of prime number, only two factor that is a prime, otherwise not prime. Sorry, two exactly two, not more than two. So three factor or three divisible any number that is not prime. So here 5 is divisible by 1 and number itself. So there is a 5 is a prime number. But 8, we can say that 8 is not prime number because 1 and number itself 8, but that other two factor we can say that 2 and 4 also divisible of 8. So there are four factor or four divisible 1, 8, 8 itself and 2 and 4 other two factor is only two factor or only two divisible. One that is a must and number itself, not other any factor. That number is a prime, otherwise that number is a not prime. So I just comment line, that is a multi-comment line for your reference. So I what is a prime, but here is a I give example 5 and 8. So you cannot fix that 5 is a odd number is a prime and even is a like 8 is a even number, so that is a not prime. Like here I give odd example that not prime number, so you can understand. So not fix in mind your. So here 9 is also not prime number. So 9 is divisible by 1, 9 and 3. So there are three factors of that number. So 9 is not prime, but 11 is a prime number. So that is a not even order, that type of meaning. 5 is a prime or 8 is a that odd even number. So that is not prime. But 9 is also even odd, but that not prime number. Okay, so that is not fixed in your mind. So I give also one example. Okay, now we can, so we can start our one. We have to not take because that is a already one all number is divisible. So we can start our loop 2, and then we can say that uh, that number of 2 I less than n up to n, we cannot itself number, so we cannot give the equal sign, and I is a plus plus. So that is our goal. And here we can also use the break keyword, that is main important point. So here if condition, and here we can n modulo I and equal to we can say that 0. So that is we can say that I just use the that break keyword. So that break use only one loop, you can come out from the that loop. If inner nested two loop is there, so break is exist that loop only one termination, only one loop come out in the break, otherwise not taking any. So here that is we can say that all are perfect, and we can say that number is a prime or not. So here come out the loop, and also we can take one flag variable if possible, but here not require flag. So here we can say that I just if condition, if that condition or n equal to I is a 2. Okay, so if there are only I plus plus there, that is we can say that that number is a prime number, otherwise not prime number, because whenever I plus plus, that meaning that is our 3 factor. But here we can check that number if modulo is a 0, so that is a not prime number. So that is a best we can simple define our logic. So let us take how it's work. So here we can say that number is not prime number, and also we can print that number. So percentage d and that n our number, and else part we can go in else part, and here I define the message, the number is prime. Okay, if exactly 2 is the factor, so yes, here first we can say that number is prime, and here if I equal to not, we can say that exactly of that number only their factor is there, so we can say that that number is a not prime. So yes, here the number is prime and other is a not prime. So here number is not prime. Yes. So yes, also here we can print the end value. So yes, what happened? Yes, first I get ch and that save also, and then compile. Yes, there is no any error, and let us first give 5. So yes, 5 number is a prime because there are only two. Because here we can what to do? Our number is a 5, and we can go to up to n equal I. So when n is a 5, and here I we can start to up to that number. So if I is remaining the that number of times I plus plus, so we can first I just trace to here that logic. So first I can watch and then I can, but I give first run, and here we can provide 8. So 8 is not prime. So why it possible? Very simple logic. So I watch taking the watch window. So here watch, yes, and then we can define first our I variable and then n variable. Yes, there are only two variable. We can very simple define our logic. Okay. So here our watch and also alter app W and taking output window and some screen I minimize. So here, yes, our previous taking output, and now you have to know very well in every my definition here trace information F7. So we can press F7 function key. Okay. Yes, now is compiled. Here is clear now. Yes, and then we can enter 5. So how it possible? Enter one integer. That simple logic. So that I is initialized. Yes, here is garbage value. Now is 2, and I n modulo I. So n is 5 and I is 2. So there is a not a break loop. Yes, just I plus plus, that is 3. I is now 3. Yes, so 3 is not divisible by that 0 reminder. So modulo operator we have to use. So that loop is not break. I plus plus again. Yes, directly plus plus, and condition check both in same time, that I is not 4 means modulo that not divisible by 4 5. Yes, now both are same and equal to I plus plus, that come out the loop because that is a not equal, so the condition is false. So our number is a same exactly I. So both are that number up to that number plus plus, that after condition is false. So we can here define simple logic. If n number and I, that two same number repeat, that number is a prime number. Look at our output. Yes, I print. And now here I define like further I scan trace, and now I can enter the 8. How it's not possible? 8 is a not prime number. So here we can trace. Yes, I is 2. Yes, directly, and n is 8 and modulo 0. So directly break. Yes, so that is a back is a here come out that break the loop. Only one, if 2 for loop there is break keyword exists, which loop that is a break, not on all loop are break. So here only one loop, but I just give that terminate only one loop. So here that if condition is true, then break. So our I is 2, but n is 8. So that is not equal. So go in else part, and that number is not prime. So very simple, I define the prime number or not. That is a simple logic I have to define for you. Also last I try next taking the 9, that is also odd number. Yes, so what happened? Yes, that 2 modulo n is 9, and that condition is not true. So directly I plus plus, but now condition is true because n modulo I is 3 and n is 9. So condition break the loop. So that is not a complete this condition. So go in else part, and that number is not prime. Yes, directly say that number is not prime. 9 is not prime because there are three factor. 1, 9 and 3, that 3 number divisible. So which number is divisible, 1 or itself, but other divisible is there, that number is not prime, otherwise it is prime. So very simple. And last time I test the like prime numbers, I get the not just 5 we have to get, now I can take the 7, that is a prime number. So let us how it's possible. So just I plus plus 3 modulo n, n is a 7, I plus plus 4, 5, not divisible, 6, not divisible, 7. So I n equal to m. So number is a prime. So yes, I think I cover very simple example of prime number or not, and very simple define for you. That is a simple loop, and we can take the break keyword. So here, that is a, here we can say that come out the loop, and that is not front, that is a backward. So that is called the backward jumping statement. Break is a backward, not forward jumping statement. That is front side and that is backward side, that type of meaning. So here that is a break only. Our main goal is we can understand the break statement of this session. So break is a keyword, break is a terminate, only one loop. And here we can define the number is prime or not using the break keyword. So whenever number is prime, that is modulo 0, and that is come out the loop, and that said that number is not prime because only 1 and that number itself is a divisible, that only 2 factor. If 3 is there, that number is not prime. So we can break our loop, not continue as previous. So we can 8 directly, I just show you. We can trace I last time for you. So we can enter 4. So that is directly say that first directly that loop is we can enter 4. 4 is a not prime number. So 4 is divisible by 2, like here 2 4 modulo 2. So that is break directly. First that is number is not prime. That is finished. Okay. So there is simple logic we have to define, and that is a break keyword, that is a jumping statement. So in C language, break, continue, and go to is a unconditional jumping statement. So avoid in programming, but we can in my upcoming video also we can see how go to is a both forward and backward jumping. So break is a here only one backward and continue is a forward. So that is distinct. Continue loop and break is a terminate the loop. So that is a different break and continue keyword. So that meaning break means break, terminate, and continue means continue. We can see in after my session. So now I can write this program to your note. That is very simple. What number is prime or not? That is using the break keyword. So I complete this session, close this file, write this program to your note in C programming book, and close that watch output and alter X quit. So subscribe my channel Ashok Sijal Academy, press the bell icon to never miss any update. Thanks for your watching, supporting and sharing my video lecture, and Hare Krishna.